Hello and welcome back to another video. In this problem, we're told that the Heaviside function is defined by h of t is equal to 0 if t is less than 0, and 1 if t is greater than or equal to 0. It is used in the study of electric circuits to represent the sudden surge of electrical current or voltage when a switch is instantaneously turned on. So in part A, we're asked to sketch the graph of the Heaviside function. So we just have a basic xy plane here. We have a value of 1, and of course the value of 0 is represented by the y-axis, the x-axis. And if t is less than 0, so you have an open circle here, the value is 0. So it's a little hard to see, but if you make that a little bit thicker, you can see that the function is going there. And we can see it is 1 if t is greater than or equal to 0, so that's a closed circle because we're including 0 this time. And it goes a little something like that. In part B, we're asked to sketch the graph of the voltage V of t in a circuit if the switch is turned on at a time t equals 0 and 120 volts are applied instantaneously to the circuit. So before time is equal to 0, we have an open circle and we have no voltage. So the voltage is 0 whenever the time is less than 0. Then at time is equal to 0, we have the switch turned on and instantaneously, therefore we're including 0, the voltage is 120 and it continues to be that. And we can notice that this is the same function as this, except we've applied, using the transformations that we've learned, we have applied a vertical stretch. All of the y values have been multiplied by 120. 0 times 120 is 0, 1 times 120 is 120. Therefore, when we're asked to write a formula for v of t in terms of h of t, v of t is h of t with a vertical stretch by a factor of 120. Using what we know, this means we have to write it 120 times h of t. I'm going to do a similar thing here. In part C, sketch the graph of the voltage V in a circuit if the switch is turned on at a time of t equals to 5 seconds and 240 volts are applied instantaneously to the circuit. So this is going to look a little bit different. Our point of interest is not at t equals 0, but at t equals 5. Before that, we have no charge. And after that, it goes up to 240. Instantaneously, once again, so it's including 5 seconds, so it's a closed circle. And here we also have the transformed version of this original graph. Here we've done two transformations, right? Instead of stretching it by a factor of 120, it's by a factor of 240. We've also shifted it to the right 5 units because our switch is turned on 5 seconds later. So this is going to be two different transformations. So v of t is equal to. So if we are vertically stretching by a factor of 240, we're multiplying h by a factor of 240. However, if we're moving it 5 units to the right, we're not taking h of t. Instead, to commit this horizontal shift, we have to do t plus or minus 5, right? That will shift it 5 units. And it's to the right, so it's minus 5. And with these two transformations, we get the graph of the voltage in terms of our original function, h of t.